All right. Okay, madam. This is now electron configuration. We'll look at now how to actually write the electron configuration without any difficulties. So it's a trick that works perfect. Okay. So now, lighting electron configuration shouldn't be that much hard, no? Those are just free marks, okay? So we'll be using SPD orbitals. Have you seen this? You say SPD orbitals. So SPD orbitals will be used. So at our study, we'll just end at SPD. We won't reach G, okay? But if you want, you can reach G, but I don't feel like reaching that far. All right, so what we do is, first of all, we'll be asked to write the electron configuration of main elements. So let me show you the periodic table, okay? So the periodic table looks like this, okay? So we can see here, we can see oxygen has 8, nitrogen has 7, carbon has 6, boron has 5, hydrogen has 1, then lithium has 3, like that. A lot of them, these are proton number, they are called proton numbers. There's also mass number, but it's not displayed here. So I'm just interested in these proton numbers, the electron numbers. Okay, so we get that proton number which is down, or the number without any values, I mean any points. So those are proton numbers. So how do we do this then? Okay, so we'll develop now what we call now the configuration trick that we'll be using. Okay, so we develop the configuration trick that we'll be using. Okay, right, so we get started now. All right, okay, so we get started now. All right, so let me just reach the page slowly. So electron configuration, master this trick each and every day. Just master SPDF, 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 just like that. So we start. So the way I'm going to arrange my orbitals, I'll say we have S, P, okay, SPD, D like this, SPDF. So this is how I'm going to arrange. Again, please write it. S, P, D, F. You can master speed, force, okay? Speed, force. Speed is caused by force. So speed, force. Again, I'll write it. Do the same. S, P, D, F. Do the same. S, P, D, F. Do the same. S, P, D, F. Okay? So that's how we'll be writing them. So now the trick goes as follow. Okay, so have you seen this SPDF that I'm from writing? Okay, so I'm going to write them like this. So these things I'm from writing. So I'm from writing SPDF. Have you seen? So I will start by this way. So S P D F. You have seen? I've repeated again. So we'll be moving twice. So each direction to the left. So if I move like this, I'll move twice. Again, I'll come starting at P, I'll move at twice. Again, at D, I'll move twice going this side. Again, at F, I'll move twice like this. But I need to number these guys. We have 1, 2, 3, 4. That's how we'll start numbering them. Okay. So from there, then, what are you going to do? So what you are going to do is we'll say, we said you move twice. So I'll get S as S, S. You have seen? Twice. Again, I'll come at P going this side, which is PS. So I'll say P, S. Okay. Again, the same P, S. You have seen? Then I'll start at D then. I'll say D, P, S. Again, D, P, S. You have seen? Then I'm going now at F. Start at F twice like this. So I'll say F, D, P, S. Again, F, D, P, S. You have seen? So these are a lot for you. And what you need to know is that, first of all, S orbital looks like this. It can only accommodate 2 electrons. That's the maximum it can. It can accommodate one, but it can accommodate maximum of what? Maximum of 2. Then P orbital can accommodate electrons, 6 electrons. Okay, can accommodate any electron, but the maximum should be 6, should be filled like this. Then the D orbital now looks like this. This can accommodate 10 electrons, so 1, 2, 3, 4. So meaning that it can accommodate 10 electrons, and they are 10 like that. Okay, if they are paired. It can accommodate even 1 electron, but we just say it can accommodate maximum of 10. So maximum should be 10. Then this one is 14, F orbital. So have 1, 2, 3, 4, 5, 6. Okay, so they are 14. There are 7 orbitals in it, but electrons that can sit, they are 14. Okay, if they are available like that. So they can it can accommodate any electron, but if maximum, they should be 14 like that. So that's how we actually, these are orbitals. Even if you are taught to write the orbitals, this is how you present the orbitals. Okay, so with this trick now, I'm going to show you something. We have seen S start at 1, we have 2S, 3S start at 1, they start at 1. Okay, then we have 4S, you just number it like that, 5S, 6x, okay, 7s, then 8s like that. So we even p will start at 2 because starting at 2, okay, 2p, 3p, 4p, 5p, 6p, 7p, okay. Then we go at d now. D start at 3, 3, 4d, 5d, 6d. We have also f start at 4, so we say 4f, 5f. Just like these are a lot for your all the configuration that will be asked to write. Okay, so this is how we go now. Pay attention. So I'm going to fill these orbitals, like I said, to say the maximum they can actually accommodate is this and this. So this maximum it can accommodate is 2, 2, 6, 2, 6, 2, 10, 6, 2. Okay, then we have 10, 6, 2, 14, 10. We have already discussed about the 4 electrons that should be there. Then we have 6, we have 2, we have 14, we have 10, we have P6, we have 2 there. So you can get, depends with the number of electrons that you have, otherwise you'll be ending. You don't have to write all of these, just master in your head to say I need to write SS, PS, PS, again DPS, DPS, again FDPS, FDPS. That's all. That's what you need to master in your head. Otherwise, there's no need of writing this. You don't have even to. There's other way of writing this, but that one I don't recommend the tail to because it's somehow confusing. But this one is very trick and fast. So suppose now you want to write, you want to write, you want to write the electron configuration for hydrogen. So the electron configuration for hydrogen. So hydrogen has how many? Let us check. Okay. So hydrogen has how many? Hydrogen has 1 electron. Okay, so the proton number for hydrogen is 1. So we'll do this. Okay, so so we are going to do this. The proton number for hydrogen is 1. So what I'm going to do is, the proton number for hydrogen is 1. So what I'm going to do is, I'll say I'll just get S and put 1 electron. So this is just 1 S. So this is the electron configuration for oxygen, for hydrogen. What of oxygen? Oxygen has a proton number of 8. Okay, so we know from the electron configuration that we said, so say S, S follows, then PS, okay, then PS. This is enough. I know 8 will be scattered here, so I'll say 2, 2, 4 already, 6. You have seen. So this means that 8, they will actually, this is 2, 4, 6. We have now 10. Even these, they will be cancelled. You have seen these are just orbitals that will get oxygen. So, and we have 4 there, 4 plus that is 10, so we need 4 there to make 10. Okay, the remaining one, so you can even judge from there to say, okay, I've already used up 4, so the remaining one from 8 is again 4, so this is the one. So this is 1, 2, always start at 2p. You remember this. So this is the electron configuration for what? For oxygen. Coming to what element can you give me? Give me, let's say, sodium, or with the 11. Okay, so with 11, um so with 11, any, okay, so with 11, so we say sodium, sodium sodium should be 11. Okay, so this 11 which is there, we say in our head, we know to say we have SS, PS. Again, we repeat the same PS. Okay, I think this will be enough for 11 electrons. So we have 2 already there, 2 there again, remaining with what? From 11, remaining with 7. Then here we'll put 6, you have seen. So this, they are giving 10. So this will be just 1. So the one which will be actually used in the configuration are these. These ones, they shouldn't be included. And remember how we name this is 1, 2, then we have 2, then you have 3 there. You have seen? So this is the electron configuration for sodium. Okay. So what about this electron configuration like for um copper, nickel, cobalt? Let me try for cobalt and we see how it will come out. All right. So there are also exception cases such as chromium and also copper. So these two will actually see how we give exception cases. So we continue with the copper. Okay, I will explain why it actually gives that configuration. So let us check the proton number for copper. So what's the proton number for copper? Okay, so copper is where? 29. So we have 29 for copper. So let us now write that. So copper has 29. Okay. So copper has 29 configuration, I mean proton number. So what we are going to do is we'll say 29. 29, that's for copper. So remember, we noticed to say we have S, we write this in our head, SS, okay? Then again PS, from that format you have been repeating, PS, again PS, okay? Then you write again DPS, DPS, again DPS. These are enough. I know 29 will be scattered. So the first one will fill with 2 electrons, again 2 electrons, 6 electrons, making 10, then 2 making 12. Again, we put on the P, the maximum is 6. So we are now having 10 there, 12, 18. 18, right? Then here there 20. Okay. From there, 20, we are remaining with 29. Remember, so this here, it will be what? So we have 2, 4, 6, 8, 10, 12, 18, 20. So we have 29 there, right? So we have 29, we have 9 there. Okay. So to make 29. So this is the configuration. You remember now how we number them. So we have one first S, 2S, then you always start at P. Number 2P is always number 2 in that range, SPD. Then we have 3 there. We have 3 again there for P, right? Because that's how we start. Then we have 4 there from 3S to 4. Then we have now for D, it just start at what? At 3. Okay. Then like that. So this is the configuration that will be used for copper. Okay. So copper now has the configuration, final copper configuration is this. So we have 1S, 2S, 2, 2P, 6, 3S, 2, 3P, 6, 4S, 2, and 3D, 9. So now listen very careful. The configuration, there's instability in this d orbital. They mark some electrons always want to sit actually. They always want to sit alone. Just that we force them by pairing them. Otherwise, they don't feel comfortable. Okay? Even you sleeping with the someone like, and it's very hot in these orbitals. Okay, reaction, as the reaction takes place, it's very hot. That's why some reaction gives heat. So even them, they are not comfortable. Even that's the reason why they jump from one place to another to actually react with other substances. They are not comfortable. Even you can be comfortable when it's hot and you are forced to actually, let's say in a prison like that. So what I'm trying to say is now this 9, there are 9 in this one. So we say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, like this. So there are 9 electrons. So what should I do then? They can't just, there is actually instability in this one. The molecule won't be stable, and the molecules always want to be stable, just like us. We want to be rich, want to have a good drive. So what will happen is that this S is comfortable. It has 2 electrons there, so it is comfortable to be alone this electron. So it will actually, there is high chance of escaping this orbital and comes there and it will sit there. Okay, so there the 1 electron will go there to that to feel the effect, which is the d half filled effect. The d orbital is half filled. So what we are going to do is we experience this type of configuration now. Okay, this type of configuration will be seen. Okay, so the type of configuration now will have 1s, 2s, 2p, 6, 3s, 2, okay, then 3p, 6, okay. Then um we have now this one, it will be 4s, 4s1, then 3d 9. So this is the configuration that this will be 10 now because we have brought the electron, okay, from this. So it has given that electron and it is now 10. So this one is now stable. Then that one will remain with the single electron, and it is actually comfortable with this because it doesn't want any force. You get? In fact, this electron can even be used to bond with other molecules. So that's how we light that. Okay. So there's what we call electron, noble gas notation electron. So noble gas electron notation looks like this. So have you seen this? Okay. So have you seen these noble gases that you're able to see here? So we have neon, okay. We have argon. We have krypton 36, we have xenon with the 54. So the xenon is 54, then krypton is 36, then argon is 18, then neon is should be 10, yeah, 10, then there is 2. Okay, so sometimes you'll be told to say light a noble gas configuration, meaning that you'll be using these metals to light as references. Okay, you'll be writing these as references. How do you do that then? Whenever you reach, let's say, an atom that exceed, let's say it exceed 54, it's 55, it has 55 proton number, so you can light wherever that 55, actually the range of 54 of those configuration, then you can substitute argon in that range. Okay, I mean xenon in that range. Again, if you have again that, let's say I tell you to select the configuration of let's say sodium or oxygen. Yes, let me say oxygen with the let me just say, what is the what metal can I use with a proton number of, let's say lithium, right? Lithium, okay, or even barium, but lithium is good. So if I'm to tell it has 3 proton number lithium, so I want you to write the noble gas configuration. So what you are going to do is you say it has 3, so have S. You have seen this actually ends there because we know that we have one S with 2 electrons, then 1 electron remaining there with 2 S. So that means that I'll use if I'm to write a noble gas configuration, which is this column, I'll get the one which is correlating, which actually at least can cater those number of electrons and remain not to jump in the other line. So what I'm trying to say is at least these two electrons, they can be occupied. Not, I can't go to 10 because I'm less than 10. So at least that one which I've jumped, I can put helium there. Helium because it represents this configuration with just the 2. Okay, helium has just the 2. So helium configuration can be given as as just the 1s2. This is the configuration for helium. So here I'll just put helium. Okay, then like that. Then I'll put 2s like that one. So this is the noble gas configuration. Again, if I'm to write again another configuration, let's say for carbon, it has what? 6. So I'll say, okay, S, P, this is enough. I know 6 will be scattered. So I'll just say 1, 2, okay? Then here start at 2. We know this. So here I'll put 2 electrons, 4. Then remaining with the 2 there. Have you seen? Have you seen? So that means that I still have, I'm less than 10. So I'm using helium as a reference configuration. So what I'm going to do is, it's just here. So I'll put helium there. Okay. Then I'll put 2s2, then 2p2. That's all. That is it. So that's the configuration in the noble way, noble gas configuration. So again, if I'm told to write, let's say the one which jumps 18, I can put, what can I put now? What can I put? The same cobalt. Let me now get cobalt. Cobalt, what is the cobalt? Is 27. Okay. So we'll try using 27, the same 27. Okay. So what we are going to do is we'll use this 27, and 27, it is above what? It's above 10, it's above argon, also 18. So I'll use argon as a reference material because I have 27. So we are saying cobalt has 27 configuration from here. So what I'm going to do is I'll say S, we know this, P, S, P, S. Again, you repeat the pattern. Again, D, P, S, D, P, S. I know this pattern, you repeat it, then you know you 27 will be scattered there because you have a lot of orbitals that will be occupied. So we have 27. So we'll say 2 there, 6 there, we have 10, 2 there, we have 12, 6 there, we have 18. You have seen? Then we have 2 there, 20, then we have 2 there, 20, remaining with the 7, right? So the configuration now is, have you seen now that it's 18? 18 ranges from here. Okay. So it's as good as me writing argon there. Okay. Because 18 has been covered. So I'll write argon there. Okay. Then I'll write 18 argon has been taken by these 18 electrons that are there. So I'll write now, by the way, before I even write that, let me now number these ones. Let me number these orbitals. So we have 1, 2, 3, okay, 4. These are the one. Then we have 2p, 3p, then we have 3d. That's why it's starting from. Remember that numbering to say S, P, D, F with 1, 2, 3, 4. That's how we start numbering. That's their initial points. So now it means that these ones have been eaten up, which are 18. So I was supposed to, these ones are not included. This is the configuration that I was supposed to have. Now I've been told to write in a noble way, in a noble gas configuration using these reference materials, group 8. So what I'm going to do, I'll say we have 4s there with 2 electrons, then we have 3d with the 7 electrons. So that is it. So the exception cases comes only when you have at least on the d orbital you have 4, you need to put 1 there. You need to throw an electron. And also if you have 9 there, you need to throw an electron. Those are exception cases. That's all. So you need to throw an electrons from the S, cross S, and you have what? You're going to have 10, the full field now. So that's how you'll be doing. So those are what we call exception cases. And the reason that you'll be told to you'll be asked to write is you give the reason due to the actually half d orbital effect. That's the reason you will explain. So otherwise, you can light a lot of configuration, but that's how you can light it. So for copper, we have demonstrated. For gold pot, we have demonstrated. I can also give for nickel. We can give for nickel, but anyway, to eat our time. So these are enough. Thank you very much. You can try just practicing. Like I've been saying, repeat SPDF, SPDF, SPDF. Even as you are writing the pattern, just write SPDF, SPDF. Then you are mastering in your head. Then from there, number those SCs, number the P's, number the D's, number the F's. Then after you number them, then you are able now to actually, those are what you call energy levels. These numbers we are putting there, energy levels, okay? So that's how you write them. So at your age, at your level, you write these. So that's how I was just giving the introduction here on how these orbitals looks like. So otherwise, that's how to light the electron configurations. There are times whereby they can tell you to say light the orbital diagram, the orbitals. How do you light the orbitals? Also, I think I can demonstrate here. So let me show you how to write the orbitals. So suppose you are asked to light the orbitals. So orbitals now will be written to say light the, after you have written the electron configuration, then you are asked to say light the orbitals. For example, now, for oxygen, okay, it has 8. So the configuration will be S, P. I think these are enough. So we say 2, 2, then there are 4 to make 8. So here we number 1s, 2s, then you always start at 2 of p, then that is it. So if we have how many energy level? We have 1, 2, 3. So we just have 2 in short. We have 1 and 2. That's the energy level. So I'll put n1 and 2 there. So under 1 we have only 1s. So we'll put that 1s like that. So you put the electrons like that. Then under 2 we have the same 1s with 2 electrons. Then again under 2 we have the p orbitals, okay? The p orbital with how many electrons? There are 4. So we say one first, you fill them singular of degenerate orbitals. In the same orbital you fill them single, then that is hands through. Then you come now to axial four. So we have 4 of them. So the fourth one will sit there. So that's how you write the orbital diagrams. If you had a lot, you would have written like that, okay? That is it. That's how we light these. So this is the orbital diagram. You can have 3, 3. You arrange them just according to the number of energy levels. Then you arrange them in the same line of energy levels. Then fill the electrons that are there. That's all. Otherwise, if you are having challenge with the orbital diagrams, you actually inbox that on WhatsApp. Thank you very much. All the best with your exam. I know you are revising, so all the best with your exam. Thank you. Okay, bye.